Okay, in this video we are going to talk about multiplying and dividing fractions. So, talking about multiplying and dividing fractions, we're going to go back to multiplying and dividing whole numbers, and we're going to think through the different models we had for multiplying and dividing whole numbers. And the first model we talked about was repeated addition. So that's what the first thing we're going to do with multiplying fractions, is using the repeated addition model. So just a quick reminder, for whole numbers using repeated addition, if I wanted to do 3 times 2, my thought process was I'm thinking add 3 2 times, or 3 groups of 2. So 3 groups of 2 would be 1, 2, 3 groups, 2 in each group. And I have a total of 6 at the end of that. Okay, so 3 times 2 equals 6, because 2 plus 2 plus 2 equals 6. Okay, so with fractions we're going to do the same thing. It's just instead of having a group of 2, I'm going to have a fractional part that I'm adding together each time here. Okay, so repeated addition, we can use either an area model or a line model. Okay, so let's use an area model first for fractions. And let's think through the problem. Our first problem, we're going to do 3 times 1/4. So if I wanted to show 3 times 1/4, my thought process here is think 3 groups of 1/4. Okay, so my 3 groups, I'm going to use rectangles here. So here's my 3 groups. I need to split all of those into 4 pieces and shade in 1/4 of them. Okay, so split them all into 4 pieces. And then I'm going to shade 1/4 of them. So this would be 1/4 plus 1/4 plus 1/4 is a total of 3/4. And the picture for the answer, I still have 1 rectangle, 4 parts make a whole. I'm going to shade in 1 from this one, 1 from this one, 1 from this one, and that's a total of 3/4. So if I wanted to do 2 times 3/4 this time, my thought process for this one is 2 groups of 3/4. So 2 groups. So here's 1 group. Here's my second group. I want to show 3/4, so I'm going to shade in. I'm going to split it into 4 parts, shade in 3 parts out of 4. So when I add them together, I have 3 parts from this one, 3 parts from this one. 4 still make a whole. So when I shade in the 3 parts from the first, it's like that. I need to shade in 3 more parts, so I need to draw another whole. So here's shading in the other 3 parts. 1, 2, 3. So 3/4 plus 3/4 equals, a couple ways you could write this. You could write this as 1 whole and 2 parts. 2 parts forming a whole, so 1 2/4. Or you could write it as 1 whole and a half a shade in there. Or you could also say I have 6 parts shaded, 4 make a whole. And those are all equivalent fractions. Okay, so that's when you're doing like a whole number times a fraction. It's easy to show 2 groups of some type of fraction, 3 groups of some type of fraction, any number of groups of some type of fraction. Now let's talk about doing a fraction times a fraction. So if my problem was 1/2 times 3/4, my thought process here is Instead of having multiple groups of 3/4, this time I'm going to have half of a group of 3/4. So I'm thinking, what is 1/2 of 3/4? Okay, so what I'm going to do is I'm going to draw 3/4. I'm going to shade in 3 parts. So now I want to take 1/2 of this because I need half of this group right here. So then I take 1/2 of it. So I'm going to split it in half, and I need to split it in half horizontally. So now I have 2 pieces, one on top, one on bottom. I want one of them, so I'm going to shade in one of those pieces. So that's my answer. And what fraction is that? Well, my answer is how many parts are shaded in? 1, 2, 3. How many pieces make a whole? 1, 2, 3, 4, 5, 6, 7, 8 pieces make a whole. So your answer is 3/8. Okay, let's do another problem like that one. What about if I had 2/3 times 1/4? So you could start with 1/4 and split into 2/3, or you could start with 2/3 and split to 1/4. It doesn't matter either way because multiplication is commutative, which means you could switch the order here. Let's do, let's think 2/3 of a group of 1/4. So I'm going to start with 1/4. I'm going to split it into 2/3. Okay, so like if you need to write that down, start with 1/4. Then split into 2/3. Okay, so I'm going to start with 1/4. So 4 pieces make a whole, shade in 1. So now I want to split this into 2/3 pieces. So I need to split into thirds first and shade 2. So split into thirds. Oops, thirds. And shade 2. So splitting this into thirds, I'm going to split it in horizontally because I can't split it super easy vertically. So split into thirds. Here's one of the thirds. Here's 2. So now I have 1/3, 2/3, 3/3. I need to shade 2 of them. So I'm only shading the part that's already shaded, the red part. So my answer here is how many parts are shaded? 1, 2 parts are shaded. How many parts make a whole? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts make a whole. So 2/12. Okay, so that's using the area model to multiply fractions. Let's move on and show the line model, multiplying fractions. So we're still doing a repeated addition here. We're still thinking 2/3 of a group of 1/4 or 2 groups of 1/4, however, whatever your problem is. So sorry about that. So now let's go over the line model using repeated addition again. So for the line model, I'm doing the same thing, it's just I'm showing it on a number line. Okay, so you're using a number line in this case. So for the example, 3 times 3/4. So for the line model, I'm thinking 3 groups of 3/4. So on a number line, I want to go 3/4 3 different times. So I need to split my number line up into fourths. Well, I mean, you could do 3/4, but that's a little bit harder than just splitting it into fourths. So starting off with 0, here's 1/4, here's 2/4, here's 3/4, here's 4/4, which is a whole. Here is, you could write it as 1 1/4, or you could write it as 5/4. Here's 1 2/4, or you could write it as 6/4. 1 3/4, you could write a 7/4. 1 4/4 would be 2 wholes. You could write it as 8/4 also. 9/4 or 2 1/4, 10/4, 2 2/4, 11/4, and then 12/4 would be 3. Okay, so if I wanted to go to add 3/4 together 3 times, the first time I add it together, I get to 3/4. So that's one group of 3/4. Add it again, I'm going to go up 1 2 3/4, since my tick marks are by fourths here. So I'm going to add 3/4 again, and then one more time, 1 2 3/4. So 3/4 plus 3/4 plus 3/4 is 9/4, or you could write it as 1 2/4. So your answer is 9/4, or I said 1 2/4. I'm sorry, 2 1/4. I said it backwards. 2 1/4, because there's 2. I went up 1/4 more. So that's your answer. Okay, so that's how you do the line model with a whole number and a fraction. Now let's do a fraction and a fraction. So if I have 1/2 times 3/4 this time. So again, I want 1/2 of a group of 3/4. So your thought process here is 1/2 of 3/4, or start with 3/4 and split in half. Okay, so let me draw 3/4 on a number line. So here's 1/4, here's 2/4, here's 3/4 right there. So here, right here is 3/4 on the number line. So now I split in half. Okay, so now I need to split in half. Well, when I go to split this in half, it's going to be in the middle right here, in between 1/4 and 2/4. So before I split it in half, maybe I should break up each of these sections into halves so that I can see exactly what number we end at, or where is in the middle right there. So if I split this section in half, this section in half, this section in half, let me go ahead and, I should have done this to start off with, I apologize. Let me go ahead and show 1 right here and split that section in half. The reason why I have to show 1 is because to figure out what this fraction is, I need to see how many parts make a whole. So what is the name of this fraction right here? It's a fraction smaller than 1/4 because it's closer to 0 than 1/4 is. The way I figured out, it is 1 part because I'm 1 part away from 0. And then the number on bottom is how many parts make a whole. Well, 1, 2, 3, 4, 5, 6, 7, 8 parts make a whole. That's why I needed to draw my whole. So that fraction is 1/8. So the next one should be 2 parts away from 0 and 8 parts make a whole, so 2/8, which is equivalent to 1/4. The next one is 3 parts away from 0, 8 make a whole, so 3/8. The next one should be 4 parts away from 0, 8 make a whole, 4/8, or 2/4, or 1/2. The next one is 5/8, 6/8, which is 3/4, 7/8, and 8/8 make a whole. Okay. So now when I go to split it in half, so half of this, if there are 1, 2, 3, 4, 5, 6 pieces, 3 pieces would be half. So this right here is splitting in half. So my answer is 3/8, because this right here is 1/2 of 3/4. Okay, so my answer is 3/8. Okay, so I hope that's helpful, using the line model and the area model to help you kind of see how to multiply fractions. So let's just go over the general rule. You would develop, in a classroom, you would develop the models of fractions first, and then once you're at that point, you wouldn't want, if you're trying to multiply like some bigger numbers, you wouldn't have to draw so much, and so to be more efficient, there is a rule for it. So what is the rule for multiplying fractions? So take a second and see if you can remember what the rule is yourself. Unfortunately, lots of times students forget the rule, especially like adults forget how to multiply fractions. The rule is to multiply across the top and multiply across the bottom. So for example, 1/2 times 3/4, I would do 1 times 3 is 3, 2 times 4 is 8, and get 3/8 that way, which is a lot faster than drawing a picture. Problem is, lots of people don't understand what's actually happening here, and the picture helps you understand what's actually happening. So when we're adding and subtracting fractions, we don't do anything with the bottom. We keep the denominator the same. So why do I multiply the denominator here? And the reason why is because lots of times when I'm doing addition, or like when I'm splitting groups in half or in thirds, I change my number of parts to make a whole. Like if you remember in this problem, we initially started off with 4 pieces make a whole, and then I had to split each of those in half, so I got 8 pieces make a whole. So that's the reason why we multiply our denominators, is because lots of times when you're doing these problems, the number of pieces to make a whole changes. Like I'm not like changing my problem, I'm just kind of breaking it into pieces to be able to find the answer in between two things. So I hope that helps you understand a little bit more about how to multiply fractions. So now we're going to talk about, this was using the repeated addition model to do fractions. So repeated addition model using area and line model. So now let's do, if you think through, what was the other way to multiply fractions was the area model, and we're going to call that the rectangular area model. Because I was already using area model for fractions and it's kind of redundant. So this is the rectangular area model for fractions. We use this the most when I'm doing mixed numbers. Okay, so this is typically used for mixed numbers. You can do it for anything. It's just this is a little bit more difficult with mixed numbers, and this is easier to do with mixed numbers. So let's start off with just a regular problem like one we've already done. If I wanted to show 3 times 3/4. So doing the rectangular area model, so think about area model for multiplication. Real quick, let me pull up a sheet of paper, a separate sheet of paper, and remind you of area model for multiplication. So area model for multiplication was if I was doing 3 times 2, I need something that is 3 units long, so 0, 1, 2, 3, and 2 units wide, so 1, 2. And then my answer is how many squares I get. So 1, 2, 3, 4, 5, 6. So my answer was 6. 3 times 2 is 6. So back over here, I'm doing the same thing. It's just this time, the rectangle I'm making is going to be 3 units long on one side and 3/4 of a unit long on the other. Since we're doing fractions, you always have to draw out to the nearest whole, and I'll show you just a second. So if I was going to do 3 by 3/4, let me do 3 long. So if this is 0, this would be 1, this would be 2, this would be 3. And if I want to do 3/4, this would be 1/4, this would be 2/4, this would be 3/4. To be able to figure out like the fractional part of our answer or the parts to make a whole, you always have to continue to the next whole. So 3/4 all the way up to a whole. So you might make a little note about that. Always, excuse me, draw your rectangle to the next whole. Okay, so let me draw my rectangle now, and let me fill in all my lines. Okay, so the difference with this one, I don't like number my parts here, because if I'm multiplying by 3/4, I don't actually want to go all the way up to a whole, so we actually just shade in here. Okay, so I'm going to shade all the way down to 3 because I want to go all, like this number 3 is all the way down. 3/4, I want to shade all the way over to 3/4. I don't want to go past 3/4. Okay, so the shaded region is my answer. The way I write my answer, the way that you write your answer is, it's a fraction. The number on top is the shaded parts. So in this case, the number on top would be 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 shaded parts there. The number on bottom, think about a fraction. The number on bottom is always the number of parts to make a whole. So parts to make a whole. Well, usually in our drawings, the parts to make a whole, this would be like one whole, but is this one whole right here? No, this is 3 holes this way by 1 hole this way. So this is actually 3 holes right here. So the way you figure out the number of parts to make a whole, if you'll get like a different colored pen and like go over the rectangle or highlight it or something, the rectangle that shows a hole would be 1 by 1. So this would be my hole right here. Okay, I hope that makes sense because 0 to 1 and then 0 to 1. So that's my hole. So what's the number of parts that make a whole? 1, 2, 3, 4. So my answer for this problem is 9/4. Or if you wanted to go ahead and work it out, that would be 2 1/4. Okay, so let's do another one like that. Let's do like a mixed number times a mixed number this time. Okay, so if I wanted to do 1 1/2 times 2 1/4. So my rectangle I'm going to draw is going to go all the way up to 2 this way, and it's going to go all the way up to 3 this way. Because remember, I'm rounding to the, I always draw to the next hole. So 1 1/2, I'm going to go down this way. So 0, I can go by halves here. So 0, 1/2, a whole, 1 1/2. This is where my shading is going to stop at 1 1/2, but I have to draw all the way up to the next hole. So 2 is where it's going to end. And then this way, I need to go by fourths. So 1/4, 2/4, 3/4, 4/4 is a whole. 1 1/4, 1 2/4. I'm sorry, yeah, 1 2/4 or 1 1/2. 1 3/4, 1 4/4 would be 2 holes, and then 2 1/4. This is where my shading is going to stop right there, but I have to go all the way up to the next hole, which would be 3. So this is 2 2/4, 2 3/4, and that's my hole of 3. So that's the rectangle I need to draw. I'm filling all my lines now. Okay, I'm shading what my problem said, because remember, this picture isn't the problem. This picture is a 2 by 3. I want 1 1/2 by 2 1/4. So 1 1/2, I'm going to shade all the way down to 1 1/2. 2 1/4, I'm going to shade all the way over. Be careful with your little marks here, because sometimes my writing doesn't line up. 2 1/4 ends right here. So I need to shade this rectangle in right here. Okay, so my answer here, your answer is the number of shaded parts. So the number of shaded parts I have is 1, 2, 3, 4, 5, 6, 7, 8, 9. And I have 3 rows, so that'd be 27 total parts. And then the number on bottoms is the number of pieces to make a whole. So to figure out the number of pieces to make a whole, you have to do a 1 by 1. Which would be this right here. So that's my whole. So that's 8 pieces on bottom make a whole. So 27/8. Or if you make that as a mixed number, 27/8 is actually 3 3/8. And you could actually see the picture. of this if you wanted to. Like, how many holes can I make here? Well, there's one of them right there. Here's another hole right here. So that's 1, 2 holes. I could get another hole also because there's 1, 2, 3, 4, 5, 6, 7, 8 parts right here. So that's my third hole. So that's 1, 2, 3 holes, and then there are 3 parts left over, 8 make a hole. So that's kind of how you see the mixed number out of the picture there. Okay, so that's multiplication using the models with fractions, with mixed numbers and whole numbers, and in the next video we'll go over division.